Stanford University.
Welcome to Stanford CS 193P. This is winter quarter of 2015. And we're going to dive right in today to some brief slide work. People at Stanford, you've got a document that describes all the grading and all that stuff, so I'm not going to go over that in lecture like I often do to start the quarter. Instead, I'm going to talk a little bit about what this class is about. Brief mention of the prerequisites, because they're pretty important in this class. Then just the quickest overview of iOS. I'm going to assume anyone who's here or who's watching this knows what that is. And then we're going to dive right into a big old demo. It's going to be a 2-day thing where I'm really going to try and introduce you to Xcode and the development environment and this language Swift that you're going to have to learn to develop for iOS. All right, so what is this class about? It's about building cool apps. As we know, why are these iOS apps so cool? Well, because the device you're going to run them on is in your pocket or in your backpack. If you write an app, you can just pull it out and show your friends. And it's highly networked and incredible graphics with animation. It's just cool all the way around. And I think you guys all know that or you wouldn't be here. But you're also going to learn in this class a lot of real-life object-oriented programming. You're taking a lot of other classes here at Stanford on things like graphics and networking and databases and maybe animation, things like that. And we're going to kind of tie that all together into a real-world class. Okay, you're going to get to see all this stuff. Now, it's going to be kind of a survey course in that. I can't go too deep into networking. I can't go too deep into databases. I can't go too deep into animation, but you'll get to see it all in a really real-world environment where people are out there building apps using that technology. So for some of you who haven't seen that before, that'll be a big bonus of this class, I think. The prerequisite of this class, number one thing is you have to be a pretty strong object-oriented programmer. If you're not a strong object-oriented programmer and you hit this class, you're probably going to go underwater pretty quick. Okay, I'm going to assume you know everything about object-oriented programming. iOS is a completely object-oriented programming development environment. And I'm not just talking about the language as object-oriented, but the entire design of it, the way you use it. If you're not comfortable with things like subclassing and stuff like that, then you're just really going to be behind the curve in iOS. So at Stanford here, that means CS 106A and B or CS 106X, and then CS 107, while it's not really object-oriented course, at least it's a heavy-duty programming course. CS 108 is a great object-oriented course. So if you've taken CS 108, you'll probably be really well prepped. 110, again, not really too much an object-oriented program, but good programming course, because there's a lot of programming in this class. In fact, all the work in this class is programming. You will not have a little bit of reading the first couple of weeks just to kind of learn this new language, but it's almost all programming after that all the way to the end, including your final project. So if you're not really comfortable with all these terms, these object-oriented terms, or if you're not just really comfortable with writing big programs, then this class will definitely be a challenge for you. Okay, so what's in iOS? What are the parts of it? It's such a big system. It's got so much in it. It's impossible for me to encapsulate it in a small little summary. But I do have this slide right here that divides it into these 4 layers. These 4 layers are approximately down near the hardware at the bottom, up near the user at the top. Okay, so at the bottom, so a lot of people don't realize that iOS is basically a Unix-based operating system. Okay, it's very similar, shares a lot of the core of Mac OS X. Okay, now it's certainly optimized for mobile devices, which have battery restrictions and things like that. But that is basically what it is. And so down at that layer, you've got sockets and you've got permissions and things like that that have to be near the hardware to work properly. But above that, there's kind of an object-oriented layer that lets you get at a lot of that stuff using object-oriented programming. Okay, and this stuff is not UI oriented. It's more kind of accessing the hardware through object-oriented programming or accessing networking through object-oriented programming, but it's a big layer there. And so we will spend a fair amount of our time in this layer because we need those primitives to build at the higher layers. Then there's this whole layer which I wish we had more time to spend on. We only get 10 weeks in this whole class. It goes by so fast, you'll be amazed, as you're probably used to with your Stanford courses. But there's a whole media layer here, both for static images, you know, JPEG and things like that, and video, both capturing video, editing video, all that. Incredible audio frameworks on this device for doing 3D audio for games and all that. Unfortunately, I get to very little of this layer. I'll try to let you know that it's in there, and then you'll know to go out and seek out, if you're building a very audio-intensive app or a video-intensive app, you'll seek out that layer. But we'll spend the vast majority of our time at the Cocoa Touch layer. So the Cocoa Touch layer, that's where the buttons and sliders and things like that are. This is the layer where you're going to build the interactivity with your end user, and so we probably spend 70+% of our time in the Cocoa Touch layer. And this is a very powerful layer. You know, you've seen things like the Maps app on the phone. There's basically an object that does almost the entire Maps app that you can just drop right into your program. Now you have Maps in your program. Same thing with web browser. If you want to put web browsing in your app, just boom, pop an object in there, call a couple methods, and you're on your way. So it's very powerful, very high level, and there's a lot going on in there, and that's where we'll spend most of our time. Okay? By the way, if you have any questions, I try to glance up. There's bright lights over there sometimes in my way, but shout out or, you know, otherwise get my attention. Feel free to interrupt. Then there's the development platform itself. Okay, what the tools we use to build these iOS apps. What's in that? Well, it's all pretty much now been funneled into this one application called Xcode 6. There are some little adjuncts that it calls out to, but Xcode 6 is everything. It's your code editor, it's your compiler, your debugger, all of that in one pretty awesome app. And so we'll be learning all about Xcode 6 in this class, and that's where you're going to spend all your time developing. You're not going to be at a terminal typing in Emacs or something. We're going to be in Xcode 6. Languages there's actually 2 languages in iOS now. They are peers. You can pretty much use either one. One of them is called Objective-C. That's the language that iOS was originally developed for. It's a language that's been around a long time, probably 30 years. It's been around, or 25 to 30 years, that it's actually been used to build stuff that's on the Mac today. So it's a very mature language, but it is also 25, 30 years old. And so Apple last summer introduced a completely new language called Swift. And Swift, you can do pretty much everything in iOS with Swift, and that's the language we're going to learn because it's a modern language. Apple did a great job of kind of building all the best stuff of all the languages that have been invented over the last 25 years, but especially the last probably 5 or 10 years into this language. It's very concise. It's a very type-safe language, but it has type inference and a lot of things that make it so that you get the best of both worlds of having type safety and not having to be constantly over-specifying everything. So we're going to go Swift only. I'm not even going to really talk about Objective-C. I just don't have time to do both languages. Yeah?
Do you think it would be important to take Objective-C in the context of doing iOS development?
Yeah, so the question is, if I'm going out into the world to do iOS development in the real world for real companies, am I probably going to have to learn Objective-C? And the answer is, it depends on the company you're at. Probably in the short term, yes, but as the time goes by, probably more and more people switch to Swift. The good thing is the underlying iOS APIs are exactly the same for both. It's just the syntax of the language, a little bit about how the language approaches calling the APIs is slightly different, but everything you learn in here about the underlying parts of iOS will totally work in Objective-C. All the methods are the same, it's just the syntax is a little different. So don't feel too bad about not learning both languages. And once you've learned this language, learning Objective-C, it's going to be pretty easy too. So good question though. All right. Of course, iOS is filled with tons of frameworks. Frameworks are libraries, basically, of objects that you use as building blocks to build your application, and we are going to be covering them. UIKit is the main one. It's got most of the user interface stuff in it. Foundation is that core services layer that I was talking about. And but there's tons of other ones. Core Motion for doing the device moving around, gyro and accelerometer. Core Data for object-oriented database, things like that. So I'll get to as many of those as I can, especially the big ones. But there's just way too many to cover in 10 weeks. And finally, I put this as a first-class thing with all the rest as a design strategy. MVC, I think I usually ask, or I'll ask this year too, how many people have used MVC in some other class? See, so it's half of you. So I'll be teaching MVC as if you don't know it. So if you don't know it, don't worry. But MVC is a way of designing your application so that it's a little more debuggable, reusable, understandable to you and to anyone reading your code. And iOS was designed with MVC from the start. So it's just an integral part to building iOS. Now, I'm going to do the demo today and on Wednesday. I'm kind of not going to follow MVC, but then next Monday, we're going to apply MVC to the demo I'm doing today and Wednesday, so you're going to get the full MVC treatment there. And I'll be having some slides on MVC on Wednesday to prepare you for next Monday. Okay? All right, so here's the demo. The demo I'm going to do is something I actually did a few years ago that really works well with Swift, which is a calculator. So we're going to build this calculator, and we're going to build it from scratch all the way. And I like to do my demos where I only type in stuff. I don't copy and paste big chunks of code in or whatever. I know I see a lot of laptops open. A lot of people like to try and follow along with me. I'm a fast typer, but usually in most demos you can keep up if you want. I don't recommend it necessarily, or certainly I don't require it. I'm going to, you'll be able to go back and watch this particular demo on video. Even Stanford people will be able to do that, because your first assignment is going to be to reproduce what I do. Okay, that is 90% of your first assignment. Reproduce what I'm going to do today and on Wednesday. So I'm not going to post the code because I want you to go through the experience of typing the code in. And you'll be watching on video, watching what I do again, and typing it all in. Okay, and I'll explain that on Wednesday. Okay, so I put on this slide a bunch of things that I'm going to cover, but I'm not going to go over it in advance. I'm just going to sit down and start doing it. So any questions before I dive in here? I know we're going a little fast, but I want to maximize your learning time. Do I have what?
Recommendation of which Xcode.
So the question is, which Xcode should you use? Well, you should just use the one in the Mac App Store. So just go to the Mac App Store. It's free. Use the one there, whatever the latest one is. If a new one comes out in the quarter, let's all switch over to it. Okay, let's just always be using the latest Xcode. Okay. No, we're not going to be using a beta or anything like that. We'll just use whatever the currently published Xcode is. Okay. So I'm going to start this demo actually by launching Xcode. So here it is right here, Xcode. And when you launch Xcode, let's hide others here, you're going to get this splash screen. And on this splash screen on the right, this is going to be all your projects. Now, this is the beginning of the quarter. We don't have any projects yet, but they'll all be listed here. So as the quarter goes by, this will fill up. You can turn this splash screen off if you don't like it, by the way. This splash screen also lets us do things like playgrounds and source code management right down here. We're not going to be doing that for a while. We're going to be focusing on this option right here, create a new Xcode project. And if you don't have the splash screen, you can get it File, New Project. Okay, same thing. Those are both the same thing. So I'm going to click right here on Create a New Project. When I create a new project, it wants to know what kind of project you want to create, because Xcode is actually used on Mac OS X and to build frameworks and all that stuff. But we're always going to be building iOS applications. And in fact, we're always going to use this template right here, the single view application. Okay, that's kind of your basic MVC starter application. And we're going to build very complicated apps out of that. But we're going to start here. So you always click on that one. Then it wants to know what you want to call your app, and we're building a calculator, so we're going to call our app Calculator. Okay? This organization name doesn't really matter. That's just going to appear in the copyright notice in the code that you write at the top in a comment, so don't worry about that. But this organization identifier, that is very important. Okay? This uniquely identifies you. Okay? So that on the next line, we can uniquely identify your calculator. So here, if you're a Stanford student, you want to use this reverse DNS notation here, edu.stanford.cs193p, and instead of instructor there, you want to put your SUNet ID, okay? Because nobody else has that but you, and that'll uniquely identify you. As I said, we're using Swift, not Objective-C, and we are going to build an app that works equally well on iPad and iPhone. That's called a universal app. You can pick to develop for only one or the other, but we are going to go universal here. We're not going to really be doing the iPad part of it for a couple weeks, but it is our intent to eventually build an app that works on both. Okay, we're not going to be using core data. That's object-oriented database stuff, so just leave that unchecked. And now it's asking where we want to save it. I strongly recommend saving in your home directory. This is my home directory here, in a folder called Developer. Okay, you can put other folders in here if you want to arrange it more, but home directory Developer, I highly recommend that. Source control, we will be talking about that at some point in the quarter, but we're not going to do it right off the bat here, so you can leave that unchecked as well. All right, so here's our first project. It's been created. So this is Xcode that you're seeing right here. This is Xcode's main screen. And the center is really what you're working on. The left area here is called the navigator. And the navigator you use to kind of choose what you're working on. But you can also do things over here like search through your whole project. That's this little guy. Look at all your breakpoints maybe, look at previous builds that you've done, browse your project by class hierarchy, all that stuff. But we're usually on the leftmost one here, which is just all the files in your project, which also can be organized hierarchically like this. And when you select something here on the left, the middle will fill up with what that you've selected. So here, I have the actual project itself selected. So these are the project settings, of which there are tons. All along the top here, you can see tons of settings. We'll go through them as the quarter goes on. And you've already seen some of them, like the bundle identifier there and the fact this is a universal app. We're not going to talk about any more of this today, this project settings business. We're going to focus here on some of these files. And even some of these files, like this app delegate, I'm just going to move that down to supporting files to get it out of the way. Same things with these image assets, launch screen. We'll get to this later in the quarter, but I want to focus on these two files right here. Okay, main.storyboard and viewcontroller.swift. Okay, in the MVC world, by the way, this is the V, the view, and this is the C, the controller. But we'll talk about MVC on Wednesday. So what do these things contain? So this main.storyboard, if I click on it, you'll see it appear here in the middle. This is our UI. Okay, this is our user interface. So for a calculator, this is going to be a little display that shows the number we're working on or whatever at the top, and lots of buttons down here, number buttons, times, times, divide, plus, minus, square root. That's all going to be here. So we're going to build this entire user interface purely graphically. Okay, we're not going to be writing code, put button at this location, none of that. Okay, we just literally with our mouse, we're going to build this whole user interface. So what's the code? What do we need any code for? Well, this viewcontroller.swift, this is a Swift file. It's your first look at Swift for most of you. This controller is going to control that user interface. That's why we call it the view controller or the controller. It controls the user interface. And that means it's going to do things that are specific to how this user interface, a calculator's user interface, works. So when we press the digit buttons, it's going to have to update the display. When we press times, it's going to have to do some multiplication and then put the result in the display. So it's controlling the display. Okay, so we'll get back to this code in a moment, but we're going to start by building our user interface. And by the way, your user interface, you can see I have a low resolution screen here, so my UI doesn't even really fit in the space here. You'll probably have maybe a little higher resolution screen than I do. But if you don't, you can zoom in and out. I'm just right-clicking. If you right-click on the background area here, you can zoom in and out. You can also do it by double-clicking. So if I double-click on this, it zooms it to normal. If I double-click on the background, it zooms out. So that way I can see my whole UI. Now, when we build a complicated app, we're going to have a whole bunch of these little square areas. We call these scenes. And a scene represents kind of a phone screen full of information. Okay? And as you've used many iOS applications, you know that you transition from one screen to another as the user goes through the app. And that's how you're going to build your apps as well. And this storyboard is eventually going to have a big map showing all the transitions between all those scenes. Okay, so this storyboard is going to get big for big apps. You're going to get to see your whole application, which is kind of cool. So we're going to start small, though, just this one little screen right here, which is going to be our calculator. So let's start building our calculator with its display. So I want to make a display. So how do I do that? Well, that brings us to the right side, the right-hand side here, this whole right side. This is called the utilities area. You can see that it's got a bottom and a top, right? We want to go into the bottom, and on the third tab right here, which is called the object library, you'll see that there's tons and tons of objects in here, okay? Dozens of these things, and we're going to get to a lot of these by the end of the quarter. But these are the things you build your user interface out of. So kind of towards the top, not all the way at the top, but towards the top, you'll start seeing things like buttons and text fields and things like that. Well, this is what we need, obviously, to build our display here, is some sort of text field. And there's a couple of them here. This one called label is static text, you see? And this one, text field, is editable text. In other words, you could touch on this one, and the little keyboard would slide up from the bottom, and you could type in it. So the calculator, you can't really touch on the screen and start typing, so we want this static text. So I'm just going to pick this up with the mouse and drag it out. Now, when I drag it out into my UI, you're going to see a lot of little blue dashed lines appearing. You see these? These are helping me put this in the right place. So I could put it right in the center, for example, of my view. I could put it up in a corner up here, which is what I'm going to do. Okay? You always want your things that you put in your UI, as much as humanly possible, to be on one of these dashed blue lines. And you'll understand why in a couple weeks when we start talking about auto layout. I'm going to do a little auto layout right here just to kind of give you a feel for it. But those dashed blue lines are going to be your best friend when it comes to building your user interface, and you'll quickly see why that is. Once you drag something out like this, these little things around it that show it's selected, right? They also are little resize handles, so you can grab them and resize them. When you resize, it also puts those dashed blue lines out there, okay? So you definitely want to, even when you're resizing, get those things lining up. You can also manipulate it directly, just double click on it. Like a calculator probably doesn't want to come up. This is going to be the initial state of this. It doesn't want to come up saying label. It probably wants 0. Or something like that in its display. There's also things you want to set about this, though, or anything you drag in your UI, that you just can't direct manipulate. And that's what the top half of this utilities windows is for. Okay, so if you look at the top half here, there's a bunch of tabs across the top, including something like this, the size inspector for setting the size of this thing. And this tab right here, really important, this is the attributes inspector. And this is an object-oriented inspector. Depending on what you have selected, you'll have different user interface here in the top. And this lets you edit attributes about what's selected. So, for example, a calculator, the 0 doesn't really want to be on the left, right? Calculators, the numbers are on the right, and they kind of grow out from the right. And so we can easily fix that with this alignment thing right here. So I'm going to click this, and you see the 0 moves over to the right. And maybe I want a bigger font. You see the font right here. I can click on this, pick different fonts. I'm going to just move it up to like 32 point. It's a nice big font. You can notice it kind of cuts off. I made it so big that it's too small, so I can always just resize this larger to make that fit. So this is how we build our user interface. It's very direct manipulation and very object-oriented, as you'll start to see when we have different kinds of objects. So let's actually run this application. Okay, we haven't built any calculator-ness about it, but we have this one field. Let's run it and see what it looks like. So how do you run things? Well, you see right here where it says iPhone 6. This actually is a selector that lets you say where you want to run your application. So you can see you can run it on an iOS device if you have one connected. I don't have one connected currently, but you can do that. And we'll talk in a Friday section, probably in a week or two, about how to get your devices hooked up. But also there's these plethora of simulators here. iPhone 6, 6 Plus, iPhone 5, iPhone 4S, iPad Airs. And you can pick one of these to run on, and it'll actually simulate that device right here on your computer. So I'm going to run on the iPhone 6. Okay, I'm just going to hit play. You see this play button right here? That's how you simulate, so play. Now it's launching a simulator. It's a separate process, and it's going to run our app in there, and there it is. Now, you might say, what, big white square? That's not so good. And the reason this is so big is because the iPhone 6 has a very high resolution display on it, okay, the Retina display, and it's way higher resolution than my computer, okay? So I actually have to scroll around. See, there's the top of it. Scroll up and down to get to it all. Luckily, if you go to Window, I'm in this simulator now, the iOS simulator. If you go to Window and Scale, you can scale it down to be smaller, and then it'll fit. Okay, so if you have a low resolution screen, you're definitely going to want to use Window Scale. Command 3 right there is another way to do it. Okay, so here's our UI, but it doesn't look too good. Okay, because where's this? We put this 0 in there, and it just never showed up. What did we do wrong? Well, we didn't really do anything wrong, and that 0 is actually there. It's just here. Let me line up these UIs. This is not necessarily exactly the same scale, but it's approximately the same scale. You can see that the 0 is actually off screen. Okay, so it's there, but you just can't see it because it's over here off the screen. Okay, and that's a problem, but that's a problem we can fix. So let's go fix that problem. Why is that thing off screen? Well, look at this UI right here. Okay, what shape is it? It's square. Okay, no iOS device is square. There's not a single square iOS device in the world. They're all, tall and thin, or if you turn them sideways, then they're long and short, or even like an iPad. The aspect ratio on an iPad is slightly different than an iPhone. So they're all slightly different, but none of them are square. So why do we design our UI in a square? Because the way you design iOS interfaces, you design them in this square, and you give everything inside the square rules called constraints about what happens to them when they get squished down, either squished down vertically, squished down horizontally, depending on what kind of device they're getting put on. Okay? So you put these rules in there. So what does it look like to put these rules in? Well, again, it's all direct manipulation. So I'm going to give some rules to this label right here to make it so that it knows what to do when this square gets squished down in any direction for any device. So what do I want the rules to be? Well, I always want this thing to use the whole width. However much width I have, I want it all. So I'm going to pin this right edge to this edge. Okay, I'm going to make it so those always are pinned to each other. And I do that with the control key. I've turned on sticky keys, so you can see down in the lower left here, it's showing the modifier keys I'm using. So right now I'm holding down control. And I'm going to control drag from the right edge of this to the container it's in. See how it's showing me what I'm dragged to? So when I drag to this container, it puts a menu up and says, oh, okay, you want some rule between that label's right edge and this thing's edge. What do you want it to be? Well, I can do a lot of things here. I could center this label vertically in this container, up, vertical up and down. I definitely don't want that. I want my label at the top, so I don't want that. I could make it the equal width, so I could make this label the same width as the container. I don't want that either, because I want this little margin there, right? But look at the top one, trailing space to container margin. This lets me pin the trailing space after my label to the margin of the container. So that's the one I want, so I'm going to click on this, and it does it. Now, see all these yellow and orange lines that appeared when I did that? That's because the system's like, okay, you've started telling me the rules for this label, but you haven't told me enough rules. I don't know what to do with this thing. So now it's showing you all the places where it's like the system's not sure what to do now when this thing gets squished. Before it was like, okay, well you weren't telling me anything, so I'm not going to do anything. But now you're starting to tell me. So what do I do? So we have to fully specify both what happens horizontally and vertically to this thing. So we've only just started here. So let's pin this edge also, because we want this edge to stay on this side. So I'm going to hold down Control and drag. And now I'm going to pin the leading space to the container margin. Okay, boom, that did that. Still have orange going on here. That's because I haven't specified anything about the vertical position of this label. So I'm going to pin the top to the top. So hold Control again, drag up here, and this is now top space. Notice that it realizes where I am dragging to and from, right? So they can give me options that make sense, like top space to layout guide here. So I'm going to do that. So now I'm starting to get blue lines. You see these lines? I hope you can see that there. They're solid blue, not orange or red. Okay, that's because they're okay. So we are okay horizontally here, but we still have a problem vertically. Now, I'm not sure exactly what the problem is vertically, because I really don't want the bottom of this. I just want it to hang out wherever it wants to hang out based on the size of my font or whatever. So I don't really want to specify anything here. So why is this orange, and how do I get rid of this? Well, anytime you have orange when you're doing this layout stuff and you don't know what to do, you want to go down to this button right here. Okay, this is the document outline. And when you click this, the little thing will slide out, a little shelf here. And this is an outline view of everything that's in your UI. Okay? And they're linked. So if I click the background, nothing is selected, then the background, the view, is what's selected here. But if I click this L0, which means a label with 0 in it, look, it selected my 0 label. And vice versa, if I click on this here, it's selected over here. So this is this same thing in an outline mode. This is really nice to have. Sometimes you have views that are overlapping and they're kind of in each other's way. You can always go here to select the one you want. Okay? And you can control drag to these over here too. It's just as much control draggable as some of these other things. But we'll talk about top layout guide, bottom layout guide a little later. But what I really want you to focus on is this little yellow circle up here. Okay, anytime you got yellow and orange problems with this auto layout business, you're going to get this little yellow circle appearing in your document outline. And if you click it, it'll slide in a list of all the problems. And so here, I'll highlight over this. This is where all the orange and yellow is. It's saying the label with the 0 in it expected the height to be 39, but the actual height is 57. Well, that's because after I set this font, I just dragged this down a little bit to make space, right? I didn't know it was supposed to be 39. I just dragged down. And so it's saying that's wrong. Now, I could just try drag it back up and meet this dashed line. This dashed line, by the way, is where it's kind of saying this is really where this thing wants to be, but the solid lines are where it actually is. So I could kind of drag it up to there, but I could be off by a pixel or something else. A much more reliable way is to click this little yellow triangle. Okay? So I'm going to click this yellow triangle. It's going to bring up this pop-up window, and there's 3 ways to fix the problems. Okay? One way, update constraints, this middle way right here. That's a way that says, hey, I want this label to be right where it is. So just make some constraints, make it up, make it happen. And it'll put some wacky constraints in there like 52 high, which is a bad constraint for it to be 52 high because this label wants to be its natural height. It doesn't want to be 52 high. So this is kind of forced constraints. You almost never want this one. Okay? Rarely do you want to force the constraints. Reset to suggested constraints would probably just work here. I'm not going to choose this one, but it would probably work. This one is going to make the constraints match the blue lines. Those dashed blue lines that I told you always want to meet, those are what's going to help the system pick suggested constraints. So since we dragged that label out to the blue lines perfectly, I'll bet if I said reset to suggested constraints, it might just work. Okay? But I'm actually going to show you this last option up on top, which is update frame. And what this says is take into consideration all the rules and move this label to where the rules say it should be. Okay? And I like this option a lot because it lets you kind of preview, do I have my little rules right? Okay? So let's try that. Let's see if we'll tell this label, go ahead and move yourself and size yourself to obey these 3 rules we put in, and we'll fix the misplacement. So let's try it. And sure enough, it did it. It says there are no auto layout issues. If I go back to my document outline, this little yellow circle is gone. If I look in my view, everything is blue lines, no yellow or red. Okay? So that's your crash course on auto layout. And we're going to talk a lot more about auto layout. In fact, even on Wednesday, I'm going to do another auto layout with all the buttons, right? The keypad buttons and all that, which is a lot more things being laid out. But let's see if this fixes our problem. Let's go ahead and run our application again. So I'm just hitting that play button. Here it is. Oh, we got our 0 this time. You see how it pinned this 0 to that edge? And not only that, if we rotate this phone, which you can do in the simulators menu, hardware, rotate, look, the 0, this got wider, and the 0 kept pinning itself over to that. And it also stayed on the top, even though this whole thing got shorter. Okay, and if I rotate back, the 0 stays there. Question?
So what did it do with the bottom edge? Like what did the actual update frame end up doing?
What did the update frame in the document outline do?
Yeah, so
it moved this bottom edge up. You see, this is only 39 pixels high now. It was 52. So yeah, it just moved it up. And if other things had been yellow, it could have moved the whole thing, right? It would move that whole rectangle wherever the rule said. But in this case, it fixed that one problem by moving it up. Good question. Okay, so that's good. All right, so that's it for auto layout. auto layout part 1. So now let's talk a little bit about connecting our user interface that we're building right here up to the code. Because we want that code to be able to talk to the user interface. Otherwise, how are we going to have the number buttons make numbers appear up here in the display, or the times button give the results of the calculation up here? We've got to be able to talk to this. So how do we do that? And the answer, first step, is we need to get both this Swift code, the controller, and this view on screen at the same time. Okay, because we're going to connect them, so we need them on screen at the same time. And there's a lot of ways to do that, but I'll do the simplest way right here, which is this little button called the Assistant Editor. All right, so I'm going to click that, and look, it put them both on screen at the same time, exactly what I wanted. Now, it's all a little crowded here. Even if I expand my view a little bit, it's like, it's all smashed in here. Luckily, the navigator and the utilities can also be hidden. See these buttons up here, these 3 buttons? This left one, if you click it, hides the navigator, and this right one, if you click it, hides utilities. Okay? So now we have both my UI, and over here we can still double click to zoom out. But the thing is, anytime we're actually connecting our UI to our code or trying to edit anything in here, you need to be zoomed to normal. Okay? For example, if I tried to select, if I'm zoomed out and I try to select this 0, I just can't. This is really kind of a bird's eye view. It's just for seeing what your UI looks like. If you want to actually work on it, you double click to zoom in on the scene that you're interested in. Okay, so here's our Swift code. I'm actually going to delete these. We don't need them for the calculator. We will need these things for future applications, but we don't need it for the calculator. And this is your first look at Swift. Okay, so Swift, as I said, very concise language, but it's basically an object-oriented language. It's going to look a lot like C. Some things look a lot like Java. It's kind of the, best of a lot of different worlds at once. Now, this import is just importing the UI portion of iOS. You usually won't have to specify imports yourself unless you start using frameworks that are not, the base frameworks, and we'll get to that probably weeks into the quarter where you finally have to do an import yourself. So this is how it automatically got put here for us. And so this is really your first line of Swift code. Okay? Appropriately, it's a definition of a class, because Swift is fundamentally object-oriented, and here we're defining a class. So what does the syntax look like to define a class? You got the keyword class, you got the name of the class. Now, this name, view controller, pretty bad name, okay? It's very generic. Really, this should probably be something like calculator view controller, something specific to this particular scene that we're working on right here that it's controlling. This is the default name it gives you. I don't want to spend the valuable demo time showing how to rename this, because unfortunately I can't just type a new name here because I got to keep the UI in sync with it, so I would have to do something in the UI as well. But for now, for your first assignment or two, we'll just call this view controller, but down the road you're going to want to pick better names. And of course you're going to be building multiple of these scenes in this class in the same app in the future, so of course they'll all have different controller names. Okay? This :UI view controller, that's inheritance. That's its superclass. Okay? Swift is single inheritance, so you can only inherit from one class. It's perfectly fine in Swift not to inherit from a class if you don't want to. All right? But here, we have to inherit from UI view controller because we want all this magic that allows us to control the UI, like that whole auto layout business, and there's a ton of mechanism in here for allowing the controller to control this UI. So obviously we do that. So all view controllers, all controllers of these little scenes always inherit from either from UI view controller directly, or they inherit from a class that inherits from UI view controller up the chain. So, and then inside this curly brace is simply all the instance variables and methods in this class. Okay? So very simple syntax to define a class. So let's dive right into making some instance variables and methods so you can see what those look like. And this was segued to because we're going to say we wanted to connect this UI to this code. So let's do that. Let's connect this label right here into this code. And then we're going to do that by making an instance variable. In Swift, we call them properties. Okay, so if you hear me say property, I'm basically talking about an instance variable, right? A variable that is part of the class. Every instance of the class gets its own copy of it. hopefully you all know what an instance variable is. If you don't, again, this class heavy object oriented, so you should definitely know that. So I'm going to make a property here, an instance variable, that points to this label so that I can update the label's text, right? I need to be able to talk to this label. And the way you do that in iOS, in Xcode, is you hold down Control, just like we did when we were making a connection to the edge. So I'm holding down Control and clicking on the label, but instead of going to the edge, I'm going to go into the code. Okay? Now, this is kind of wacky. I know a lot of you are like, what? Into the code? Yeah. So we're going to write it in the code here and let go. And it's going to say, oh, you want to make a connection between your UI and your controller. No problem. What kind of connection you want to make? And we want to make what's called an outlet connection. An outlet means an instance variable or property that points to this thing in the UI. And all it needs to know to do that is, what do you want to call this property? And this is the display of my calculator, so I'm going to call this display. And it already knows the type of the thing is UI label, of course, because we drag from here. Don't worry about this week. I'll talk about that in a moment. And then we just hit connect, and it creates an instance variable or property right here in our controller. So this is a great opportunity to look at the syntax in Swift for creating a property. And there's a couple of things on here that are not normally part of it. This is the main syntax for creating a property. Let's quickly look at this thing to get it out of the way. This is not really part of the Swift language proper. This is something Xcode puts in here so that this little circle, do you see the little circle in this gutter appears? This little circle, when I mouse over it, look what Xcode does. It shows me what this line of code is connected to. Okay? So that's really cool. And you're going to see that's really valuable later in this demo, is being able to find out what things are connected to. So that's all this thing means here. You don't type this in yourself, that when you control drag, it puts it there. This week, if you come from other languages, you're used to things like garbage collection to clean up the heap, or maybe you even have to alloc and free things yourself manually in some languages. None of that in Swift. In Swift, all objects live in the heap. Okay, all classes, instances of classes live in the heap, and the memory for them is managed for you. Okay? You allocate them as much as you want. As soon as there's no pointers to them, they get cleaned up. And it's not garbage collection. Okay, it's reference counting. It's actually counting references to them, but it's all automatic. The only thing you ever have to be maybe interested in is this week business, which is less than 1/100% of the time. And for the first 4 weeks of this class, forget about week. It'll automatically happen when you do this control drag, but just ignore it. But the main thing to know is that all that memory management is happening for you. Also, this instance variable right here, which is a pointer to this object. Notice there's no ampersands or stars or any other kind of syntax that says this is a pointer. Okay? If you have a instance variable or property or local variable that is an object, okay, it's always a pointer to it because objects only live in the heap. Okay, so you don't need all that extra stars and ampersand, any of that business from other languages, okay? This exclamation point, by the way, I'm going to talk about in a few minutes, has nothing to do with this being an object, okay? This is a totally separate thing. We'll get to it. All right, so let's look at this. This is the syntax for defining a property, okay, an instance variable. And it's very simple. You got var, short for variable. So that's what this is, a variable. The name, this is the name of it, display. Okay, that's just the name of this property. And then :UI label exclamation point is the type. Okay, that's the type of this instance variable. So again, I'll talk about the exclamation point later, but obviously this thing is pointing to this label so that we can talk to it. And we'll be doing that in a moment. Okay, questions? All right. Let's talk about another kind of connection we can make. Let's start putting some buttons in our calculator. So I'm going to go back to the utilities window, okay, by pressing this button over here. Go down to the bottom, go to the third tab over here, the object library. And instead of a label, this time I'm going to drag out a button. Okay, I'm going to put this button here. Now, just to be different, I'm not going to initially line it up with a blue line. I'm just going to put it kind of in space out here, and I'll line it up with a blue line later. Okay. But I don't want to forget to do that, though. I always want to do that. I'm going to do it later just to show you it can be done. So this is going to be, let's say this is going to be one of our number buttons, like the upper left corner of our keypad is a 7. Okay, again, I have the same thing over here, okay, with the attributes inspector. I can change things like the font. Let's make this be 24 point, let's say. I can resize. Notice that when I resize, it'll actually tell me the size. See it saying there what size it is? I can also set the size maybe with this size inspector right here. Type it in exactly, maybe 64 by 64 or something like that. We don't usually do that. We want things to be kind of their natural sizes, but just wanted to show you that there are other inspectors over here. So we have this 7. Now when this 7 is pressed, what do we want to happen? Well, we want numbers to start appearing up here in the display, right? So that's something our controller is going to have to do. So when we touch this button, we kind of want this button to send a message to our controller. And we do that the exact same way as we did this one. We hold down Control, drag into our code. When we let go, though, we're not going to do an outlet connection this time because I don't want an instance variable here. What I want is a method, right? A function on my class, a method. Everyone understand the word method, I hope. Okay, so we wanted to send an object-oriented message to our controller. Okay, that's great. So I'm going to pick action. Losing my voice here. Bad time to have a little cold, but. So I'm doing an action. So an action is a little different than an outlet. Okay, an outlet means an instance variable or property. Action means create a method for me. So again, it wants to know the name of the method. So what does this thing do? Well, when I press 7, it appends a digit onto the end of whatever's already in the display. So I'm going to call it append. I could call it append 7, but I'm actually going to call it append digit because I want to have one method that all of my buttons use, right? I don't want to be copying and pasting a whole bunch of methods. That would be really bad code. But if I'm going to have one method, then I need to know which button is sending me this message. Okay? Luckily, when you have an action, a message being sent here, you can specify that it has arguments. You see right here where it says arguments? And it could have no arguments, or it can have the sender, which is the button here, as the argument. The only tricky thing here is, and I'm not sure why they did this in Xcode, hopefully they'll change in the future. By default, the type of that argument, which is right here, is any object. Now we're going to talk about any object next week, but we don't want any object here. We know that the sender is a UI button. So I click this little blue thing and switch this to UI button. When you're doing your homework, if you forget to switch that to UI button, you'll be sad. Okay? So don't forget. And obviously the event that the message is going to be sent on, touch up inside, just means the user touched on this button and the touch went up while it was still inside the button. That's all touch up inside means there. All right, so when I connect this, I'm going to get a method with one argument, which is a sender, which is a UI button. So let's take a look. So here's your first method declaration in Swift. Okay, again, it's got this little IB action thing, which is kind of like IB outlet. It puts a little dot in the gutter. Okay, so you can see what this thing is connected to. So this is the normal Swift method syntax. Starts with func because function, basically a method is a function in a class. Here's the name, append digit. And then in parentheses, all the arguments separated by commas. We only have one argument though. Here's the name of the first argument. That's the name we're going to use to access it inside of our method. And here is the type. Okay, it's a UI button. Notice no exclamation point there, by the way. Okay, if this had a return value, if this method returned something, this one doesn't, but if it returned something, it would look like this. Arrow, the return type. Okay, so that's how you specify a return type. Okay, pretty simple syntax. And then inside here, we just type whatever we want this thing to do when one of these buttons is touched. So what do we want it to do? Well, okay, first of all, before we do that, let's go ahead and make more of these buttons because I need 7, 8, 9, 4, 5, 6, all this. So let's copy and paste the button. When I copy and paste the button, notice that I'm using the blue lines to put it perfectly lined up. Okay. Also notice that they're both sending this message, right? See how they're both sending the message? Because when I copied and pasted, it copied that aspect of it as well. So there's another one. I could select all 3 of these and copy and paste. Okay. I could select all 6 of these and copy and paste. So I can quickly make my entire keypad. I just need to edit the title. Now, if while I'm editing these titles, sometimes you're clicking around in here and you're not a very accurate clicker, or you just get out of control clicking here and you moved it out of the way. Okay, no problem. You can just put it right back in. Okay, use the blue lines to your advantage. And we'll put our 0 down here. And I don't need these buttons, so I'm just selecting it and hitting delete. That's how you can get rid of something. And I promised I was going to put these all on blue lines, so I'm going to do that. I'm going to put it right underneath the 0. So here's a blue line that means underneath the 0. And then I'm going to put it this edge. So now you can see that the blue lines are not just the edges, but they're other objects, like the other objects in the keypad, and also now the display rather, at the top. So I've got all these buttons. They're all sending this message, append digit. So I need to figure out which one is sending it so that I can do the right thing. So let's start writing some code inside the method. So the first thing I'm going to do is declare a local variable. This is just a local variable inside this method. And I'm going to do that by saying let digit equal. So I want this local variable to be the digit that was pressed. Okay? So first thing that's quite different here is what's let? Okay? Why isn't this var, right? Because var means variable. What the heck does let mean? Well, let is exactly the same as var, except it's a constant, which means you're going to assign this right off the bat, and it's never going to change in this method. Now, Swift makes a big deal of this, and I love this feature, because if I'm reading this code, I know that digit is never going to be changed. This might be, it might have a dozen lines of code, which, by the way, you shouldn't have very many methods with many more lines of code than that, okay? You want people to be able to kind of see what a method's doing. You can use other methods, call other methods if you need to get more code in there. Here I can rely on that not changing. That's big for readability. You'll be surprised how much more readable it makes the code to know that this is a local variable, but it's constant, only set at the beginning. Yeah.
Like variables have the same naming conventions in Swift, like Java, they're like the naming conventions like all caps. Or
yeah. So yeah, the question is, why don't I call digit like all caps digit or something like that, so I know it's a constant? That would be a programming style thing. Generally in Swift, they don't do that. And I'll show you why that is in a moment, okay? Why you don't really need to do that, because you can very quickly find out the declaration of any symbol anywhere with one click, and you'll see that. Good question, though. All right, so I want to let the digit equal the number that's on the sending button. So I'm going to have to send a message to this button. Okay, I'm going to have to somehow access this button. So I'm going to have to do sender something. Give me what your title is. Okay, so this is a good time to talk about the documentation, because being a good iOS developer really demands that you are good at navigating the documentation. Luckily, the documentation is really well plugged into Xcode. For example, if I want to find out about button, all I need to do is hold down the Option key, okay? And watch what happens now. As I mouse over things, everything, it turns blue with a dashed blue line under it, okay? If I click on it, it gives me a little blurb from the documentation about this thing. So it's saying, here's a button is a class, here's its inheritance, here's a little bit of what it does, and really awesome at the bottom here, here's a link that takes you to the detailed documentation. So I'm going to click this little link right here. It's going to bring up a documentation window with a UI button in it. Hello. Did I not click that right thing there? Oh, I hope I don't have a network issue here. Okay, well, I guess I'm not connected to the network. That's the problem. So it's getting this off the network. Okay, so imagine that there was documentation here. And it would have, along this side here on the left, all the instance variables or properties and methods of UI button. And you could click on any one, and in there it would have a full description of it here, and all the types that it referenced you could click on in here, and basically it's a hyperlinked documentation system, as you can imagine. I'll try to get the networking working on Wednesday, and we'll take a look at this. But if I was looking in here, I'd look down in the section that says getting the button's current state, and I'd find that there's an instance variable or property there called current title. okay? This is unfortunate, I'm not going to be able to link these things. But, so how do we access a property or call a method in another object? Well, it looks exactly the same, whether you're calling a method or accessing a property, which is you use dot. Okay, this is the same syntax that's used in a lot of languages, is to do dot. And so when you do that, Xcode's going to say, oh, well, here's all the things Button knows how to do. Okay? And as you can see, Button knows how to do a lot of things because it inherits from a class that inherits from a class, inherits from a class that all have lots of methods in them. So when I looked at that documentation, I found that current title was the thing I wanted. Now notice as I start to type a C, it's already cutting down the things that could be starting with a C, and then CU, they cut down even more. I can type tab to get to the first ambiguity point. Then I can type T, okay, and then tab again. I'm here at current title, and then I can press return. Okay, so there it is, digit equals sender current title. What's going on here in terms of sender title? Let's go ahead and print this out to the console just to see what's going on. So I'm going to println, which is a function, a global function, that takes a string, so I give it a string. And inside that string, I'll type digit equals. And now I want to embed the value of digit in this string. And Swift has a really cool feature, which is backslash, open parentheses, close parentheses. If you put that in a string, and then inside there you put some expression, then it will evaluate that expression, turn it into a string, and embed it in this string. Okay? So it's really easy to println values by using this backslash parentheses. Okay? So let's go ahead and run and see what happens when we press these buttons, see what kind of result we get. It's not going to be quite what we expect, but let's see. All right, so here's our UI. We've got our buttons. That's a good start. And now, the console, where's the console? Well, watch this. I'm going to press a button, 5. The console appears at the bottom here. See this down here? This is the console. And it's saying digit equals, optional 5. Okay, how about a 9? They're all optional. What the heck is going on here? Okay, this is crucial to understanding Swift. This is probably the most important thing to understand that people don't quite get right from the start. So we're really going to focus here on understanding what optional means right there. Okay, so let's go back to our code and look at this. Oh, and by the way, when the console appears down here, you can make it go away with this little button, or you can just drag it out of the way. Okay, but sometimes it's nice to have that console still there so you can look at your output while you're, reacting to whatever you found. In fact, we will leave that there so you can see the optionals. All right, so what's going on here? Well, what's happening here is, well, first of all, don't you find this a little bit odd? Let digit, I didn't put a type. See that? What type is digit? Okay, there's no type in there, no type information whatsoever. So does Swift have untyped variables? No, it's the exact opposite. Swift is very strongly typed, okay? All variables have a type. You have to specify a type. But Swift is also incredibly good at what's called type inference. So we can infer the type from the context. So here, I let digit equal whatever this is, this current title, and so it just made digit be the same type as this, okay? Now, back to the question earlier, so what type is that? Well, if I hold down option, okay, just like we used option to go look into the documentation, we can also option click on our own variables to see, are they constant, are they variables, and what type are they? So watch this. Option click, it says digit is of type string question mark. Okay, string question mark. That question mark means optional. So there is a type in Swift, it's a type called optional, okay? Optional, that type, can have only 2 values. One value is not set, okay? This optional is not set. Either it has never been set or someone set it to the not set state. They unset it, if you want to think about it that way. So optional, one value is not set. We call that, there's a symbol for it in here called nil, N-I-L. Okay, that means not set. That's the value of an optional, not set. That's the only thing nil means in Swift is option. This is an optional, the value of an optional that's not set. What's the other value that an optional can have? Well, the other value is something. It's set to something, okay? And the type of that something is what is specified next to the question mark. String. So really you can almost think of the question mark there, that's the type, optional. And that string to the left is just saying, if this optional is set, what type of thing is it set to? In this case, a string. So we would call this an optional string. But it's really an optional. It's not a string that can be nil. It's an optional that can be a string. Everybody cool with that sentence? That's an important sentence to understand. Okay? So this got to be an optional because this current title method right here returns an optional string. Let's look at that. So I'm going to option down here, click, look at this. This is the documentation for it. It's a instance variable, a property on UI button. Name is current title. The type is string question mark. And this little get means it's read only. I can only get the current title. I can't set it. There are other ways to set a button's title. You can't set it with this method or this property. So it's an optional. So that's why this ended up being an optional. All right. Well, that's all wonderful. How do I get the string? I don't want an optional. I want that button's string. And the way you do that is you unwrap the optional, meaning you look in there and get the associated value with exclamation point. Okay, what happens if I put that exclamation point there? Well, first of all, let me show you that when I put that exclamation point, look what happened to digit. I'm option clicking on digit. It's not an optional anymore. Digit turned into a string because I unwrapped the optional that came back from current title and got the string out of there. But what happens if this is nil? What happens if this optional is nil? In other words, the button title has never been set. Crash. Okay? Crashes your program. So if you use exclamation point to unwrap an optional, and that optional's current value is not set, nil, then it will crash your program. Now, a lot of you might be like, whoa, my programs are going to be crashing all over the place. And because there's a lot of optionals in iOS. I mean, a lot. Okay, most things are probably optionals because most things, it makes sense they could be in a not set state at some point. And yeah, in this case though, maybe you want your program to crash. Okay? You might want your program to crash because if you had a button that never had its title set and it's sending a pen digit to your controller, you probably want to have that crash so you can find that bug before you ship your program. You see why sometimes crashing is good? Now, if you don't want to crash, there's a way to get around that as well, and I'll show you that a little bit later. But for now, understanding that that's what this exclamation point does, it unwraps that optional and crashes if it's nil. But if it's not nil, it gets to the string, or whatever the optional type is, out of there for you. So now let's go ahead and run again. And we're going to see that digit equals is going to say the number. Okay, it's got the string off the current title. No more optional in there. Okay? Good. All right. So now what are we going to do with that digit? We got the digit. We want to append it onto the end of this display right here. Okay? And so let's just do that by saying display dot. Now, again, if we have the documentation, I'd go look in the documentation and it would say, oh, there's a property on UI label, which is what display is. Display is a UI label. There's a property in it called text. See it right there? And actually, you can even see right here the type of that. It's an optional as well, because this label's text might not have been set either. Okay? So it has to be an optional string. Okay, so I'm just going to set that equal. Now, display.text is an optional, so what values can I set it to? I could set it to nil. That'd be legal because it's an optional. See, no warnings, no errors. That would clear out that display. It would not be set to anything. Or I can set it to a string because it's an optional string. So I'm going to set it to a string, and the string I'm going to set it to is display.text, what's currently in there, plus digit. Okay, so I'm going to append that digit on. Let's get rid of that. Okay, now this has an error here. Why does this have an error? Anyone volunteer why this is an error? See, it's pointing right here. There's an error. Back there.
The display.text is an optional string.
Bingo, because display.text right here is not a string, it's an optional. And you can't add a string to an optional. You can only add strings to other strings. So we need to turn this into a string by unwrapping it. And again, yes, this would crash if the display currently has nothing in it. It's not set. Okay? Everybody cool with that? So let's run again. All right, so now 5. Oh, it put the 5 on there. 6, excellent. It's kind of working. I don't really like that 0 though. That's kind of weak. 0, 5, 6. That 0 should have gotten cleared out, right? When I first typed that 5. And that's because we really need some way in our controller to know whether we're in the middle of typing a number right now. Because if we're in the middle of typing a number, we want to append. But if we're not in the middle of typing a number, we want to start a new number, right? So let's do that. And I'm going to do that by adding a property. Okay? var user is in the middle of typing a number, which you might say, oh my God, that's a terrible variable. Now I have to type that over and over. This is the last time I'll ever have to type that, okay? Because Xcode is always going to escape complete it for me. Okay, so long names are perfectly fine in terms of typing load anyway. So I like this name, so I'm going to keep it. And it's a bool, okay? So I'm typing, it's giving its type. So here's var, name, type. And notice, look at this little error right here, okay? Okay, sometimes you're going to get errors in Swift that are completely incomprehensible to you because you haven't learned enough of Swift. This one's kind of like that. You see it says class view controller has no initializers. And that's because, and pay attention, in Swift, all properties have to be initialized when the object is initialized, okay? You can't have a property just sitting around not initialized. They have to have a value. Now, if they're an optional, their value could be nil, but they have to have some value. So we can't have this have no value. Now, there's two ways to give it a value. One is with an initializer. Unfortunately, I'm not going to teach that to you until next week, so you can't do it that way. Another way is just to say what it equals right here. Okay? And boom, gets rid of all our errors. Obviously, we don't start out in the middle of typing a number, so we're good to go here, right? So now we know whether the user's in the middle of typing a number. We can go down here and say if the user, now again, I'm just going to hit tab to jump past this, maybe a couple times. But if the user's in the middle of typing a number, then we'll do what we were doing before. Otherwise, we're just going to set the display.text equal to the new digit we just typed, okay? And we're going to say that the user is now in the middle of typing a number. Question?
Why would we have to do with display initialize?
Why did we not have to initialize this? That's a fantastic question, and I'm going to talk about that on Wednesday because there's only 1 minute left. But that is a great question, and it'll also, when I talk about it, I'm going to tell you why this is an exclamation point and not a question mark. Because I told you that optionals are made with question marks. So why the heck is this optional? Because that's what it is, an exclamation point. So we'll talk about that next time. All right, so let's go ahead and run one last time here. And hopefully this 0 will be cleared out. It is, and hopefully this will continue to append. It is. So we're in a great spot right here. We've got a calculator. We can enter numbers in it. Next step is we got to make it do some calculating. And we're going to do that next time. So I will see you then.
For more, please visit us at stanford.edu.